Hello there. This tutorial will be focused on integrating with E and ln x. So simply, I am sure you guys know already that anti-deriving is the same as finding the integral of whatever expression they give you. So in other words, they'll give you something that looks like this. I apologize if it's blurry. But when they give you an expression like this, that's to show you that this whole expression right here is the derivative of whatever they want you to find. So by the end, you should get an f of x. This already being the original, the antiderivative of this, plus c. So this whole expression is the antiderivative of the integral over here. Or in other words, you're basically just going from f prime x to f of x, if that makes any sense. So let's start off with an easy problem using E to show the rules with E. So number one, really easy. I'm just really using it to show the simple rule that you must know. So it's e to the power of 2x over e to the power of x dx. We must always include dx, always, when you're finding the integral, of course. So simply you rewrite this as e to the power of x dx. Why? Because you can simplify the 2x over the x, because we know that when there's an exponent over an exponent, you can simplify by subtracting the lower exponent from the higher exponent, and the higher exponent is on top, the 2x, meaning that it'll be positive, so it'll be e to the power of x, because this is just simplified right here, really. Just makes it easier. And it's just a simple rule when integrating that the integral of e to the power of x is simply e to the power of x plus c, of course, is to show that this is the antiderivative of this. So it's really easy. Just to show that rule, we're going to move on to a little bit more complicated one. Simply complicated because we will be using u substitution. Pretty sure you should already know how to use that. So the example I'd like to use is the integral of e to the power of 2x minus 5 dx. Simply, we're gonna, we have to find a u. In this case, I will make u, find it. Okay. I'm sorry for all the movement. So, we will make u 2x minus 5, this part right here, right, the only algebraic area. And we're going to differentiate that to solve for dx, because we know that we're going to substitute whatever we solve over here into this formula in a bit. I'll show you that in a bit. So du will equal to dx. Simply, we derive this to get this, right? So the derivative of 2x minus 5 is 2 times dx, and we're going to solve for dx. So what we do, we have to bring the 2 over here to get the dx by itself. So, I don't know why the screen just got kind of pink. So, what we're going to do is to get rid of this, we know we have to multiply both sides by 1/2. We know that this will cancel out like that. And we'll get 1/2 du. And that's our dx. So we're going to rewrite this as e to the u times the dx that we just solved for. You see how we're going to substitute these dx with the dx we solved over here. So it'd be times 1/2 du. And then we can simply rewrite that. We can take the 1/2 out, put it outside, like I just did there, and leave the u here, e to the power of u times du. And now we're going to simply, really easy, just integrate that. So it'd be 1/2, times, well, we know that the integral of e is always e. This is pretty much the same thing. So it'd be 1/2 times e u plus c. And we're just going to put back in u. So it'd be 1/2 e times 2x, well, e to the power of 2x minus 5 plus c. So I don't know if you understood what I just did there. Simply, it's all just rewriting, substituting in the u over here and the dx over here with the du. Taking out the 1/2. You leave that. We know that the integral of EU is always EU again. And basically, you just rewrite it all and put the U back in, and that's your answer. 1/2 times e to the power of 2x minus 5 plus c. So yes, after solving, this is really, these examples are just to show you that when you're integrating with ln or natural log, well, it doesn't even really have to be in the original expression they give you here. Simply know the rule here that when they give you a constant to the power of x, you will always rewrite it, the antiderivative, the original they give you here, over ln of the constant plus c. It's just a rule right there. This is just to show you that there's that rule. And also over here, like I showed you earlier while working it out, that in the integral of 1 over x will become ln of x. That's just a rule there too. So this is just to show you how to deal with integrating and natural log. So this tutorial was really just to show you the little rules that there is when it apply to evaluating when you're integrating with e and natural log, and I hope you found it helpful. Thank you.